the thing. So I'm going to pull up the assignment and then I'm going to share it. Okay. So today, okay, so bring this over here, take you, move you over here. Okay. So let's go ahead and share screen, the whole screen. Enable chat. There we go. Let's see. I'll have to fix that so it's done. So, if you reserved office hours today, I had forgotten to move them today, so I will honor that time and meet you. Quiz 2 covers, I think it covers up to 4 loops. Can't remember if there's 4 loops on it, but it covers
and 4 loops.
What? Turtles and 4 loops.
Turtle and 4 loops.
Yeah, turtles and 4 loops. It should cover everything through module 4, right? So when we're at a quiz, when a quiz covers everything up through that module. So here, let's go ahead and talk about Pig Latin. In-class exercises. So click on this. Now this used to be a homework, but I like doing this in class because it's actually fairly good. So for those of you who did not have English as a first language or lived outside the US, you may not be familiar with Pig Latin, but that's okay. It's fairly simple. It is a completely made up language. It is more of a game than a language. Okay. So the entire idea is that we are going to write a program that will allow users to take words and transform them into a simplified form of Pig Latin. I say simplified because Pig Latin, it will work for most words, but some other words will have some issues with. So Pig Latin or Ig Play Latin Day is a game where basically we take English words and move them around. So for instance, for a lot of the words, what we do is that we take the first couple letters and then swap them to the back and move them to the back and add AY to the end. So letter becomes Ederle, foo becomes Ufe, bar becomes Arbe, or bar becomes Arbe, spam becomes Amspe. So it's a fairly simple rule to start out with, which is that for anything that starts with a consonant, we can transform it into a Pig Latin, or anything that starts with multiple consonants, we can take all the letters before the first vowel. So, hey, like spam over here, and we move them to the back, and then we add AY to the end. So for instance, Charizard becomes Arizard Che. Okay. So, now, so it is that's fairly simple as far as understanding it goes. Now, the reason it's called Pig Latin is because when we do this kind of thing, it does sound Latin-ish, like if you don't know what Latin sounds like. Okay. So, now the other thing we can do is that we're going to use a very simple way. We're going to do a very simple transformation with words that start with vowels instead. It gets more complex. For words that begin with vowel sounds, the word is left alone, and most commonly yay is added to the end. But in different parts of the world, there's different dialects. So, explain. Typically, what I'm going to do if we have a vowel is that I'm going to move for somewhere. I'd like to move the vowel to the end. So Alakazam becomes Lakazamwe. So we'll try that, and we'll probably functionize it so we can try and experiment a bit more with it. So this is the output of the program I wrote in Java. The output's going to be the same in Python. It has been the same in Python. And then when you type done, the program ends. Okay, so you keep typing, you type a word, it gives you the Pig Latin. You type a word, it gives you the Pig Latin. You keep doing that until it becomes done. I would guess it does. All right, so, but when Laser, you're gonna have to start the next episode yourself because I'm busy teaching class and Mama's busy making cookies.
I couldn't hear what he was saying.
Oh, he wants the next episode.
I have to let the dough cool.
All right. So how do we do this? Well, the main thing is that we're going to use a while loop. A while loop is as I've mentioned before, an indeterminate loop, meaning it's like an if statement, but it runs until the condition is no longer true. So what we're going to do is that we are going to split this up into multiple functions. We're going to create a program called string manipulation that contains functions in the list below. We're going to create a main function, which does most of the work. Now, despite the fact that it's listed first and called main, it's actually the least important for right now because that's everything else. All the features will kind of go together into it. We're also going to write something called find first vowel, which takes in the string and returns an integer. And now the reason for that is because knowing where the first vowel is in a word is extremely important for Pig Latin, because that will tell us what letters need to be moved. And then we'll write a convert to Pig Latin, which takes a string and returns a string. The return string is the Pig Latin form of the input word. So we convert it into Pig Latin via these two mutually exclusive rules. If it starts with a vowel, we're going to move the vowel to the end of the word and add way to the end. Otherwise, we're going to take all the letters before the first vowel and move it to the end and add a. If there's no vowel, we're just going to not change it. Okay. For reference, y is not a vowel in this context. Okay. So let's get started. Okay. Let's go ahead and save. Let's see. Desktop. We are going to go ahead and call this, I'm just going to call it piglatin.python rather than string manipulation because that's shorter. All right. So let's go ahead. And so rather than trying to work on the main function and all that other stuff, I'm going to be doing I'm going to be basically, let's start by working on find first vowel, which given a string, find first vowel. And what we want to do with find first vowel is given a string. So we're given a word. I want to return the index of the first vowel in the word. Now, why did I put -1 there? It's just a placeholder for right now. But I want to find where the first vowel is in the word. So let's think about how to do this abstractly. Okay. What I could do is that I could go through each letter in the word or each index in the word and say, okay, what is the letter at this index? If it's an A, an E, an I, an O, or a U, if it's a vowel, then I will return, then I found the index, so I'll just say, hey, here's where the first vowel is. And because I'm going to be going left to right, it will be the first one. Because had I not, I would have returned already. Cool thing about return, once you return, it stops it exits a function. So you can use a return to just stop it and to just stop a function. So we'll just keep going through it, and if we find one, and if we find the vowel, then we're going to be done. If we can't find it, I'm just going to return -1 because I can. So you're going to need a for loop for that. And the for loop will start like this. Let's go index in range len word. Okay. So in other words, actually it's going to look like this, but I mean, this is kind of, so letter is equal to word index. And why I'm showing you this is actually I'm going to set it up to make it a bit nicer looking for you. So what I'm going to do instead is I'm going to just modify this a bit. And right now I'm just going to print out letter, right? Print index, comma, letter. I'm going to teach you something. I'm going to teach something to you here. Okay. Find first vowel, and let's go with happy, right? Now, what is this going to do? It prints out Z at index 0. Can everybody read this? Or is it too small?
I can see it.
Okay.
If it was a little bigger, it'd be nice.
Let's go to preferences, settings. Is that true for both, for all the font sizes, or? Oh yeah, debug console, that's tiny. Let's move it up to 28. Let's see. I think. Terminal integrated. There we go. Let's bump it up to 32. And let's bump this up to 36. That should be nice and easy to read now. Okay, 0. So at index 0, we have H. Then at index 1, we have A. And then at index 2, we have a P. And then index 3, we have a P, right? That makes sense. Just simply 0, 1, 2, 3. Like that, right? Those are those are what we have here. Now, everybody agrees that this terminology over here is a bit clunky. For index in range, length word, right? That's kind of clunky, right? So, and really we care about, and this goes for index, but then we immediately grab the letter. But we need the index because if we just simply go 4-letter in range, sorry, 4-letter in word, you know, we don't get the index out. And there's a way to go and get the first, you know, to do that. But I mean, it's not as easy as it could be. So what I'm going to do here is actually show you something else. So this is going to be pretty cool, and it's going to possibly look weirder, but I think it looks better. For letter, index, comma, letter in enumerate word. Now this is pretty cool over here. And notice that this produces the same output. Okay. Basically what this does, but when we say enumerate word, it says, hey, I'd like you to give me both the index and the thing at that index together. Does that make sense to everybody? So here we're declaring two variables separated by a comma. Okay. So you've got, I'd like my index and my letter. I could call them Alice and Bob, right? I could call them Alice and Bob, but it doesn't really matter. Right. So maybe I'll call them Allison letter this time. Again, they're just variable names. But here what it says is that I essentially am giving you the index and the thing at the index. Does that make sense? Or did I lose people?
I'm kind of confused, like why it can be any word. Like, I don't know.
Because it's for the same reason we can use X in an equation or Y in an equation or A in an equation, you know? It's the same. It's because it's up to the person to decide what to call, to give it a name. So
true, but I guess like it is printing the index. So it seems
right.
like the word matters, but
it does. So actually on a kind of on a really important level for readability, it does matter what you call it, right? What I'm saying what I mean when I say it doesn't matter what you call it, I mean Python doesn't really care. But as a human, I very much care what you call it. Does that make sense?
Yeah.
So, but the first thing will be the index, and the second thing will be the thing at the letter. I think there's only two things it will do.
Could you reverse the order of letter and index in that, like the for statement?
I mean, but if I did, your
letter would be the index technically.
Yeah.
Okay.
Yeah, we basically we get into the problem that was previously mentioned, that what you call it matters.
So I have a question. Does the enumerate function require that you list two variables?
Yes.
Okay.
So the enumerate simply says, hey, give me two things and I can iterate. Although if you don't want one of them for some reason, you can just simply leave it blank like that, right? Or you could just give it a name and not use it. But this is for a very specific, this is for a specific case that comes up commonly where you want both the index and the thing at the index. If you called it something else, how would it know to find the index? Because it always knows that the first thing you list is the variable that refers to the index. So if I called this I, it would still know that that's the index. If I called it X, it would still know it's the index, because this is the first thing, and the first thing gets the value that represents the index. The second thing gets the value that represents the what's inside of that index. Make sense? Now, the enumerate really only comes into play when we're in a for loop. I've yet to see it outside of for loop anytime I've coded, because Python's a very cool language that's very hacker friendly, and you can do whatever you want to it. I'm sure you could use it outside of the for loop, but in all practical senses, you're never going to see it outside of the for loop. Mm-hmm. All right, so with this in mind, take this code, which I'm going to go ahead and paste into chat if you need it. Badoop. Right, take this and try to use this, complete this code to find the first vowel. Return the index of the first vowel. Okay, so for this one, find first vowel, it should return 1. If find first vowel should give back, so if I do this, print find first vowel happy, that should be that should give me 1. If I do find first vowel, that'll give me, if I do echo, this will give me 0, not 3. Okay. And remember, returning something will exit a function. So give you a couple minutes on that. Having multiple returns is fine. I've never really heard it's bad to have multiple returns. Although, I mean, it depends on what you mean by 2 returns. If you have 2 return statements, that's fine. It's okay to have multiple return statements. I mean, how else would you do recursive programming without multiple returns? Okay. So this one, there's a couple of easy ways to do this. Let's go with the straightforward way. It's a very straightforward answer we're going to do here. So print. So if letter equals A or letter equals E or letter equals I, you get the idea here, right? Right. And easiest way to complete that is to copy paste. So U O I. Right. So if letter is A or letter is E or letter is I or letter is O or letter is U, then congratulations, we found a vowel. So what we're going to do is return index, because that means that that index is our first vowel. Okay. And if we can manage to get all the way through the for loop without returning, we're just going to return -1 to say, hey, I don't think we found something. Make sense? So now this is the wordy way to do this, and I'm sure a bunch of you are about to ask in chat, is this way to do it okay? And the answer is yes. If it works, it's fine. Let's go ahead and print this out, by the way, just to kind of show. So we got 1 and 0, which is what we wanted. But there's a couple other ways in Python that we can do this that are a bit nicer, such as if letter in, we can actually create a vowels list over here, right? If vowels list is equal to, let's see, A, comma E, comma I, comma O, comma U, and we could just simply stringify each of these guys. It makes sense. So we've got A, E, I, O, U like that. So if letter is in vowels. So if this is one of the, so if this letter is one of the listed strings in here, then awesome. Another thing we can do, third way to do it, is to do it like this, A-E-I-O-U. Just make a word called A-E-I-O-U that represents our vowels, or string A-E-I-O-U that represents our vowels, stored in vowels, and say, hey, if this is in the vowels word, if this letter occurs somewhere in the string, then that's true. It's a vowel. All of those ways of doing it were equally valid. I happen to like this one the least. I happen to like this one the most because it involves the least amount of typing, and least amount of complexity. Okay, so now let's go ahead and now we can use this to, what we're going to do rather than jumping into these next suggested function over here, convert to Pig Latin. I think I'm going to take a different approach, which will modify this for next year. Convert to Pig Latin, which takes in a string and returns a string. So we're going to build the pieces of this. The first piece was finding the first vowel. So let's go ahead and write a convert. Let's write a function called Pig Latin. So we're going to define two functions here. Def Pig Latin val word, pass it, which just means don't do anything. And we're going to do, how in the world do you spell consonant anyway?
C-O-N-S-A-N-A-N-T.
Oh, I ever met consonant. Okay, I was completely off. Consonant. It's such a funny word. Pig Latin consonant. Okay. I got my PhD in computer science, not in spelling. The computer does that for me. Okay. Doesn't help that I do all my reading with audiobooks anyway. Okay, so we've got Pig Latin vowel, Pig Latin consonant. So this, given a word that starts with a vowel, given a word that starts with a vowel, we'll return, we're going to transform this into the Pig Latin form of it. Otherwise, we've got Pig Latin consonant, which says, hey, this word we're going to transform this word that starts with a consonant. Should we do it like this? Yeah, we're doing it like this anyway. Okay. Don't think it was necessary to do it like this. Really? Yes, yeah, this is a terrible idea because they're one-liners. So let's just go ahead and scratch this entire terrible idea. Pig Latin. Mine says letters not. Did you define letter over here?
Where is that again?
Where do you get letter dot defined? Where's your error occurring?
1 second.
So, all right. Convert to Pig Latin. This is going to take in a string and return a string. It's going to take the string and it's going to say, hey, this is a Pig Latin form. It's going to give me back the Pig Latin form of the word. And if I can't transform it, I'm just going to return the word. So right now I'm just going to echo it back out. So there's a couple conditions here. So let's just write it in kind of a error-laden code. If true, right? If true, so I'm going to put here in comments, if the word with a vowel, so if the word starts with a vowel, pass. Else, let's go ahead and do else. Doesn't start with a vowel. Okay. So first, let's go ahead and figure out this if statement. If the word starts with a vowel. So how do I know if the word starts with a vowel? Well, there's a couple ways I could do that. I could say, hey, if word 0, the first thing at index 1 equal, if that's in A, I, O, U, and I could just kind of echo what I did over there earlier. But I mean, I want to be a bit lazier than this. I know this looks pretty lazy, right? But we have this nice nifty thing over here called find first vowel, right? Just going to copy word. So I'm going to find the first vowel in the word, right? I'm going to call this Vowel Index. Okay. And I'm going to just simply say, hey, if Vowel Index equals 0. Now, why did I do it like this? Because this is actually something that we definitely will need to use later. When we do each of these things. So if Vowel Index, if the word starts with a vowel, do one thing. If the word doesn't start with a vowel, do another thing, right? Everybody agree that this is the format that we need?
Yeah.
Okay. So the question is, so let's start about this. So if the word starts with a vowel, move the vowel to the end of the word, and additionally add way to the end of it. All right. So first off, are fireworks going off in the distance? Because that's what it sounds like. Okay. Anyway. So we can do this in one line, like I mentioned. So we want to take the vowel, move it to the end of the word, and add way to the end of it. So really, we want this to be 3 parts, right? Which is, right, we want to take the word, move the vowel to the end of it, right? Rest of the word, the vowel, and then we're going to add way to the end of it. So how do we do that? I'll give you a hint. The easiest way involves slicing this. So go ahead and take 2 minutes to try and work that one out.
What was the slice function again?
So the slice function isn't precisely a function. It is a notation. So for instance, and I'm going to boot up idle here because this is what idle is super useful for, which is just having a nice console, right? What I can do is that if I've got word over here is equal to happy, right? Let's go ahead and say word is equal to happy. So now if I decide to slice this word, here's how I can do this. I can say, hey, word
You should turn the TV off in the back.
word 0 to 3 would give me the first 3 characters of this. It would give me hap. So it's the same notation as range, which is beginning to the end, not including the, beginning to the, but up to and not including the end. So this gives me index 0, 1, 2, but not including 3. Now, why does it work like that? Because we can just simply say, hey, go, we can take this and subtract this number for it to get the number of letters. Remember also that we can just simply say, if I do word, 3 to the end like that, that's also valid notation. Same with word, colon, 3. And that says go from the beginning up to the end, or up to, but not including 3. So you can leave out parts of that you can leave out the beginning to say start at the beginning, and you can leave out the end to say end at the end. And remember, if you just need one character, no slice needed, you just simply say that character.
Happy doesn't start with a vowel.
No, it does not start with a vowel, but it's a good example of how to. Happy should give you 1. Okay. Here we go. Cat does not want to stay. All right. So easiest way to do this one is as follows. What we want to do is basically set, let's do this from the back going forward. Something you can totally do, right? We want to add way to the end. Boom, done. Next, we also want the vowel, right? We need to take the word, and just move the vowel to the end. So how do we get the vowel to the end of it? Well, we know the vowel's at index 0, so we can just simply say word 0. There it is at the end. Now the rest of the word, we need everything but the first letter, right? Because that first letter gets moved to the end, right? So what we're going to do is we're going to say word, go from index 1 up to, but don't include up to the end of it. So everything starting from the first index. Does that make sense? So everything but the vowel at the very beginning of the word, right? Everything but the, then take the vowel over there and add way to the end of it. Doesn't work for a lot of vowel words, but it's okay. My word looks weird, okay? But for the purposes of writing the assignment, it was a good function. Now, if the word doesn't start with a vowel, we have to do a very similar process. Return word. So we need to return 3 parts of the word, right? We need to return rest of the word. Or rather, let's go ahead. Everything from the first vowel on plus everything up to the first vowel. Okay, right? So if you remember the rules for this, we're going to take everything up to the first vowel, but not the first vowel itself, move it to the end, right? Move it to the end of the word and add AY to the end. So it's a similar process, except we can't use 0 and 1 here. Instead, we're going to have to make use of another variable that we've already created because we need to know where the first vowel is. Don't overthink it. Oh, and you should try this before I give you the solution. Rose, you have noticed my intentional bug. And I do swear it was intentional because I don't want to jump ahead too quickly. But yes, if I don't use a vowel, then we're gonna have very interesting behavior. Okay, so don't worry, I'm aware of it. And I do have a plan to fix it. Okay. Participants, that's what I need. And mute all. Also, if you're wondering why I just don't give you the answer and give you plenty of time to work on it yourself, it's because also if I was doing this just straight through in for the entire lecture, your eyes would start to droop and you'd start wandering onto Twitter or Instagram or something, or Reddit, or God forbid, Facebook, and get distracted. And with small bursts like this, we can get it done much more reasonably and give you the chance to work on it. So let's go ahead and now take a look at this. So the word doesn't start with a vowel, return everything from the first vowel on, everything up to the first vowel, not including it, and A. So again, let's just build it in reverse. So we know what it's going to end with. It's going to end with an A, right? If I've got Charizard, again, great example because it has multiple letters and also it's a lot of people's favorite Pokemon. But, you know, so we can do plus A right onto the end, tack that on. Now what we need is like, right, the word itself that gets manipulated, right? The A is extra. The word itself that's getting manipulated, we're taking all the consonants before the first vowel, all the letters before that first vowel. So let's go. So first off, it's going to be in the word. We're going to be doing some kind of slice. Okay. So it's going to be starting from the beginning. So we know that we could put a 0 or leave it blank, but I'm going to be explicit and say, okay, start at the beginning, and we want to go up to, but not include the first vowel. So what should we put here?
Would you just put vowel index?
That is correct. We just put in vowel index because find first vowel did all the heavy lifting for us earlier, right? We know where the first vowel is, so we can go up to, but not include that, right? We wrote a function that tells us where that first vowel is. And right, because putting in a for loop like this inside of all this stuff would just make it nasty looking. So, okay, so everything up to the first vowel.
Could you also like not have the 0 there?
I could not have the 0, but since I was like doing a fill in the blank kind of style thing, I wanted to put the 0 to remind myself I'd already done, or to indicate that I'd already completed that part. Make sense?
Yes.
These two statements are functionally identical. So okay. So now if the word, so now everything from the first vowel on. So that would be word, and we want to do another slice. Okay. From the first vowel on, so we want to go to the end. So I'm just going to leave this part, the end, blank. So what index do we need to start at?
Word index.
Vowel index, yeah. Not vowel index +1, because remember, this goes up to, but does not include the vowel index. And if we did vowel index +1, then neither of those statements would have the vowel in it. So it looks pretty messy, but let me get rid of the comma, the comment rather. It's gonna, and I will just simply say, and yeah, it looks a bit messy, but you can parse what it means. It's not as bad as the inverse as the inverse square root. Famous bit of code. Look it up on Wikipedia. The comments I don't want to. The comments are quite expletive filled on it because it is a particularly bit of magic hardware there. Fast inverse square root that calculates. By the way, that calculates. So you got your square root, right? Which is like, what is the square root of 4? It's 2. The inverse square root, it asks, what is 1 over the square root of x? So if you want to know what the inverse square root of 4 is, it would be 1/2, I believe. If I'm remembering this correct. Is that correct? Rachel asks, would that be the same as doing word vowel index to -1? I don't know. Rachel, does that work on your end? I like, my instinct says yes, but I'm like only 95% sure.
I think so, but then again,
I think it might leave out the last letter.
Okay, I'll check.
I think that leaves out the last letter because you're saying I'm going up to, but not including the last index. Okay. And the reason we like to leave this blank is because otherwise, if we couldn't leave it blank, we'd have to put in len word over here. And that is a very, that gets a bit wordy. That's why they pay me the big bucks. Okay, now let's go ahead and try this. So let's go ahead and we are going to print convert to Pig Latin. Right, convert to Pig Latin. And that gives us Apihe, and here with echo, it moves the E to the end and adds way, so it becomes Chowe. Right, if we try Charizard. Again, I haven't made it case sensitive, and that's okay. We can worry about that later. So, okay. But what if we put in a word that doesn't have any vowels in it, like sky? Becomes Iske, which I suppose is okay. But that's not what we want. Said the rule set, my rule said, hey, if it doesn't have a vowel, just return it completely unchanged. Now, the reason it won't hit over here is because we've got if, else, return word. So what I'm going to do right here is just to fix this is actually a very quick fix. I'm going to turn this into an else if else statement over here. And remember, we had one signal left over from find first vowel, which is if vowel index is equal to -1. -1 is often used as a way to say it wasn't there. So, and that's the way I used it in find first vowel, which is that if it didn't have a vowel, then give me -1. So if it's a -1, I'm just gonna get the word back. Could you also use none? We could use none. It's I think when you're returning integers, it's better practice to use ints. Sorry, it's better practice to use ints rather than returning nuns, because if you accidentally try to mess with a none, you can get into some weird exceptions. You don't want to mess with null pointers in Java, same with nuns in Python. All right, so we've got this going one at a time, which is actually the bulk of the work. But now we wanted this to work until the user types in the word done. Okay. So we're going to write ourselves a main function. Now there's a couple ways we can do a main function. I'm just going to write a def main over here. And then what I'm going to do is I'm going to call it down here. This is not necessarily the Pythonic way to do it, but whatever. And what we're going to do is say, well, for right now, let's just go ahead and just like simulate the loop rather than doing it until the user does this. Let's not worry about taking in the user input and checking to see if they put in done yet. Instead, let's go ahead and assume that we're going to run this maybe 5 times. So let's write it as a definite loop first. So for I in or blank, because we're not going to use it, in range 5. So this loop, whatever's in here, will run 5 times. We're going to take our input. We're going to say print input, enter a word. Even though mine didn't have a prompt, we'll go ahead and prompt the user over here. Enter a word. We'll say word over here is that, and then we'll print out convert to Pig Latin. and print out convert to piglet. Actually, we'll call it pig is equal to, rather than making it look horrible, we'll say pig is equal to convert to pig Latin word and and then print pig. We're just going to do this 5 times. So we've defined our functions, and then we call the command main. So now we're going to run it, enter a word, apple, banana, orange, banana, and banana. Okay, ran 5 times, and then it stopped. Okay, so the way a while loop works is that you do the same thing for a for loop, okay? But type of while instead, it looks more like an if statement, such as while let's see what we can do. Yep, so well, right now, if I wrote while true, what would the behavior of this be? Let's go ahead and run it. Just while true. Well, I mean, if I put in a vowel, it's going to keep going, or a non-vowel. While true just means that, yeah, while this is true, keep doing this. The true is never going to change. So this is what we call an infinite loop. Let's see. Task manager, did I have Python? Do I have it running in the background still? I believe I do, because let's see. Did you define word over here?
Wait, where is that? The define main word equals. Oh, no. No, I didn't.
All right, so just making sure that it exited out, which is using more CPU. Interesting. Okay, and now what is eating up all the CPU time here? It says zoom is, which is interesting. So, okay, now we're back to normal. Let's go ahead and kill the screensaver as well, because we background as well, because we don't need that. Okay, so instead what we kind of want to do here is that I'm going to put something called, I'm going to create a variable called finished is equal to false, because I like being able to do this. So while we are not finished, that looks like very good, that looks like, grammatically correct stuff. While it's not finished, this is effectively the same as saying while true, right? Because not finished, finished is false, so not false, that becomes true, right? That'll run forever, except we have the chance now to change it here, right? We can change it because our program specifies when the user enters the word done, we should stop. Now, how can we stop? We could stop by changing finished to true. Make sense? Right? As soon as, if I were to say, hey, if I were to turn finished into true down here, it would only run once, because it would say, run it. Let's type in apple, and we get pull away. Make sense? So it stopped because finish is equal to true. If I didn't have this, it would be an infinite loop. So for the last part of this, see if you can, well, you'll need to use an if statement alongside this input statement to figure out the best way to make sure that it stops when the user types in done. So that's our last part for here. another excellent question, Rose. We want it when the user types in done, it shouldn't try to convert done into Pig Latin. It should just stop. Okay. So let's go ahead and finish this up. And then I will tell you about the potential extra credit you can get in this assignment. Okay. So this one is fairly straightforward actually to do, which is that, hey, so we take in the word, right? We're going to do that regardless of whether or not the word is done or not. So that's going to be before we make any decisions. When we need to make a decision, one alternative versus another, that's when we know we need an if statement. So we'll say if word equals done. Now, if we want, so if word is equal done, we'll do one thing. Else we'll do something else, assuming that I can hit the keys correctly on a keyboard, because apparently that's difficult. So if the word is done, figure that out in a second. But if it's not done, then what am I going to do? I'm just going to take the word, convert it into Pig Latin, and print it out. That's good. Okay, so if the word is done, in that case, we're done. So we're going to say finished is equal to true. Boom. All we need, and now we can say Charizard, and then we can say done, and then it will just quit like that. Now this is used. Now we want to use a while loop here, and Python's nice in that it's structured so that it forces that while loops that for loops are determinate. Well, while loops can be determinate or indeterminate, but they're primarily used in indeterminate cases like this. In other words, we use while loops when we don't know how long the loop is supposed to run. We don't know, and by that I mean we could use a break, Kyle, but it's better practice to avoid it when you can. It's better practice to avoid it when you can. But so a while loop, we don't know how many times the user's going to enter a word before he gets bored and enters done, right? You could use a return statement as well, but that's effectively using the same as a break here. I mean, if it works, first off, end of the day, if it works, right? Just in the way I like to program, I like to do it like this. So again, while loop, we don't know how long this is going to run. The for loop, yeah, you can argue we don't know how long it's going to run because we don't know how big word is, but we know that how long it is going to run is dependent on the length of the word, right? Could you have it in the while statement while word is not done? You could, but that imposes some new problems, such as having to define word up here on line 19 before we start, as well as doing what's called fence posting, and you're going to be basically writing some repeated code. This way we don't have to write any repeated code. But again, if it works, it works. I mean, if you were close to, if everything was right with the indentation, then you would have gotten it, I'm sure, if I gave you more than 3 minutes to do it. All right, so let's talk about extra credit here, because I did apparently have extra credit. All right, so this assignment is worth 60 points, and there's 10 potential extra credit points here. So 3 points are available for if you upload this, right? And if you upload this, just comment that you had done the extra credit. You don't need to demo it, but just let us know you've done the extra credit so you can get credit for it. So extra credit. Write and call an additional function called reverse. What reverse will do is it's going to take it in a string and it's going to return the mirror image of the string. It's going to print it in reverse. So for instance, your input should now look like this: letter, then ederle, which is the Pig Latin, and then redel, which is letter in reverse. Foo is going to become oofe, and then reversed it's oof. You know. So, okay, so just simply rotate that. 7 points requires requires you to do some basic encryption, which is going to be a very interesting thing, but I think it's worth those 7 extra points to do. Write an additional function that takes your input and encrypts it using ROT13, which is that means it is a Caesarean cipher that with a degree of 13. What on God's green earth am I talking about? Okay. What in God's green earth am I talking about? So, right, if I'm doing something, if I'm encrypting something using a Caesarean cipher, that means I rotate I increase all the letters when I write something. So all the A's would become, anything. If I'm writing a message, I'd take all my A's and instead I'd write a D if for degree 3. If then I take all my B's and encrypt and then that would become E's, all my C's would become F's, and so on and so forth, right? Now that's that's the classic Caesarean cipher or a ROT 3. What I want you to implement is a ROT 13, and what's cool about ROT 13 is that you can take something in ROT 13, encrypt it, and then you can encrypt it again. So you can take a word, encrypt it with ROT 13, then encrypt it again and get the same output. Let's see, def main finished is not equal to false while not finished, enter a word. If word is equal done. Else pig is equal to pig. Yeah, so best I can ask is what is it giving in the shell? It really depends on what the shell, what your error in the shell is. So, all right. So I will upload this tonight.